The communications industry is expected to undergo tremendous change in the near future. The global demand for more bandwidth to support mobile applications such as smartphone usage for accessing data and video online is driving this change. A rapid build-out of next-generation communications infrastructure in the wireless and wireline industries is being specified today and continues to evolve.
Standards are in flux. Time to market pressures are intense. Customers need a way of very rapidly moving from their core idea into a real implementation that they can move into production with.
There is a disruption starting to happen, and we're at the beginning stages of that. ASICs are indeed, I think, going the way of the dinosaur, and even application-specific standard products. These are standard products that are also solutions that you can use. They're also perhaps not going to have the growth, we think, as programmable logic, just because it lacks that customization aspect.
As well as programmable logic has done, it has been held back by a couple of inherent inefficiencies in the technology in terms of performance and particularly in terms of cost. As those two inefficiencies become less and less with new technology introductions, that will allow programmable logic to move more into the larger spaces that are currently occupied by ASICs and ASSPs.
The price performance has simply been too limited in FPGAs. The overhead associated with programmability necessary within those architectures has just been so great as to prevent these devices to actually be used in a large portion of the volume applications. That's where Tabula technology really comes in. It's a step function advancement in price performance. We can bring into the marketplace all the value add, all the positives that FPGA technology can deliver, but at the same time really address the fundamental limitation that's been there since the very inception of FPGAs.
You might have heard of Moore's Law, which says that you can double the amount of stuff that goes on a chip about every 18 months. Our competitors can take advantage of Moore's Law, and so can we. But we have a separate benefit that is unique. Each new generation is also faster than the previous one, and we can transform that time benefit into a space benefit with space-time. The 5x advantage we have today is the worst we will ever be, and by going from 5x to 7x to 10x, not only are we pulling away from FPGA, but are rapidly catching ASIC. This is how we're going to take that $70 billion market for ASICs and ASSPs.
Roughly every 24 months, manufacturing technology will allow Tabula to put twice as many transistors on its chips, which translates into twice as many programmable logic gates. However, because Tabula time slices the logic gates on its chips, Tabula should get an additional benefit from Moore's Law.
It's not a gigantic jump in physics or a huge bet on an impossible dream about yields. It's just a rethinking of how customers use the silicon and the tools.
The combination of onboard large density memory and SerDes channels that Tabula provides communications OEMs goes a long way to solving a lot of the problems that they have, especially in light of the increased demand for bandwidth that they're encountering today.
With advantages ranging from 2 to 5x in critical areas such as compute capabilities, memory capacity, and signal processing capabilities. Tabula's ABAX 3PLD products deliver key value to our target OEMs in the communications segments.
Things like smartphones have gotten way ahead of the infrastructure. One way to expand the bandwidth is to spend an enormous amount of money on more pipe. Another way is to use the pipe much more intelligently. And devices like Tabula's support the second approach.
The main markets driving the growth of PLDs are the industrial and the communications market. Particularly within communications, we're seeing a lot of uptake of programmable logic in the 4G wireless world, as programmable logic is an essential part of the infrastructure that's going up to support the new 4G standards. iSupply expects that the market for core silicon solutions, again that's ASICs, ASSPs, and programmable logic, will be in the range of about $130 billion by 2014.
Tabula could become a third major competitor in the FPGA market alongside Altera and Xilinx. Those were the two industry leaders for the past 20 years. So, yeah, it's a big deal.
Semico believes that the approach Tabula has taken is both unique and innovative, and is something the entire semiconductor industry needs to take note of.
The thing that makes Tabula interesting is that from the user's point of view, there's a lot more gates in there per dollar. And from the user's point of view, there's a lot more potential maximum speed than the trend line would have predicted.
This funding represents a resounding validation of Tabula's 3D programmable logic technology. It's also a reflection of the investor enthusiasm about the market potential of Tabula's products, as well as a significant vote of confidence in the Tabula team. We have a very ambitious market entry plan ahead of us. We've got a very aggressive plan for continuing to advance our technology.
Steve Teig, he's an EDA guru, clearly in Silicon Valley. Dennis Seegers, former executive at Xilinx, has put together a team that has the very, very good prospect of being successful in this market and thriving.
We invest in Tabula because of the nature of the change that they were aiming to create in the programmable logic device marketplace. The quality of the people is the most important thing. We now have working devices, and we now have multiple design wins.
The kind of disruptive businesses we back, I think, are first and foremost defined by the quality of their management team. And I'm quite certain that Dennis and Steve and the team they've assembled is the best operating executive management team in the semiconductor business today. And I don't say that lightly. I know that there's some very big and successful companies that I'm comparing them to.
I think Tabula's potential over the next several years is almost unbounded. We aim to be a multi-billion-dollar company that transforms the electronics industry to take not only FPGA sockets, but the ASIC and ASSP sockets alongside them, and to be in electronic devices all the way from consumer products like digital cameras and televisions, all the way up to heavy-duty equipment like Cisco routers and so on. And I absolutely believe we can do that, and we'll build a large company that results.
Spacetime is now ramping into the marketplace. Our customer engagements are ramping up as we speak. Much of our focus now is working with our customers and going from their basic design specifications into full system implementation. The technology is sound, it's real, it works, it delivers on its promise, and it's qualified for production, and it is ramping as we speak. And we're very excited to have it to this point. But in many ways, this isn't the finish line. This is the starting line for us.